Okay, so today we are starting our last unit, Unit 10, which focuses on acids and bases. So we're starting off today. The first lesson focuses on strong and weak acids and bases. So the term strong and weak, it's the same type of terminology like we just had in Unit 9 when we talked about strong electrolytes and weak electrolytes. They're being used the same way. It's just now we're specifically talking about acids that could be strong or weak and bases that could be strong or weak. And so what you're going to see in here is that acids and bases are all electrolytes. And so if you have a strong acid, that's a strong electrolyte. If you have a strong base, that's a strong electrolyte. It's going to conduct electricity really, really well. If you have a weak acid or a weak base, those are going to be weak electrolytes and they will not conduct electricity as well. Okay, and so that those terms strong and weak, it's the same sort of definition. It's just we're applying it more specifically to acids and bases now instead of just general electrolytes. Okay, so there is a simulation you're going to be using. You can, depending on your preference, I embedded it here. So if you are fine, just like kind of scrolling between, the questions that are down here in the little interactive lesson and kind of going up to your um, uh, simulation, you can do that. Like it works. I can click introduction here and I can click everything. It's right here embedded in Canvas. If you prefer to have them in like different windows or different tabs, when you start your lesson on the second page, it's actually going to link to it if you want to open it up in a separate tab or a separate window. So it's up to you how you prefer to do it. Okay. But the first thing here, it starts with just a brief introduction to some of the properties and some of the characteristics of acids and bases, because they have some things that they are in common, but then they have some things that are kind of opposite or they're different. So this left side over here where all the backgrounds are red is going to be referring to acids. The side over here that's blue is going to be referring to bases. Typically, in a lot of like textbooks or like online materials, acids are usually associated with the color red, and bases tend to be associated with the color blue. And the reason for that, and I'm going to kind of scroll to the bottom, kind of get ahead. The reason for that is because of how they react with this substance called litmus paper. Litmus paper it's just a little thin sheet of paper that's been soaked in this chemical called litmus. And litmus is something we call an indicator. Indicators are chemicals that when they come in contact with certain pH levels, they turn different colors. And so pH is, we're going to get to that next week, but pH is how we measure how acidic something is. So if something has a lower pH, we say it's going to be an acid if it's below a certain number. If it's above a certain number, something is considered basic. And so when you have a litmus paper, if you dip it in a solution and it turns red, that means that that solution is an acid or it's acidic. If you dip it in a solution and it turns blue, that's going to mean that that would be a base. And so that's why a lot of times when you see like visual or like any kind of things in textbooks or online websites or references or whatever, they tend to associate acids with the color red and bases with the color blue because of how they react with litmus paper, okay, and the color that they turn. So that's why on here, the left side that's red is going to be acids. The right side that's blue is going to be bases. So first thing is taste. So acids typically, one of their characteristics, they taste sour. Bases, on the other hand, taste bitter. Okay. And I'm going to kind of elaborate a little bit because pretty much anything that you eat, if it tastes even a remotely sour, that substance is acidic. Most foods are acidic, even if it's just a little bit acidic. So things that are very high in acidity are going to be like your citrus fruits, oranges, limes, lemons, grapefruits. The more sour it is, the more acidic it is. So oranges, yeah, they're a little sour, but they're also really sweet. So they're going to be less acidic than like a lemon that's like really sour. Okay. Sour candies, like if anybody like to eat those like gummy candies or the hard candies that are really, really sour, they get that sour flavor because they've added, usually if you read the ingredient label, usually it's going to say that it includes citric acid as an ingredient. Citric acid is the acid that's in citrus fruits that gives it that sour taste. So they will add citric acid to sour flavored like candies or even sour sodas. Like if you look at like the bottle of like Sprite, any of those lemon lime flavored sodas, they all have citric acid in them. And that gives it that kind of citrusy sour flavor. Other things that might be sour, but like you don't really think of as sour. You think of like milk. When milk goes bad, we said there's a phrase like the milk turned sour or the milk soured. That's because it had a chemical change, and there are some of the sugars in the milk are being eaten by some like bacteria and things. And so when it sours, it's because it's turning more acidic. Okay. So anything that tastes sour is going to have some kind of acid in it. Okay. Bases taste bitter. Most bases we cannot eat because bases are usually pretty poisonous. Okay. One of the very like few bases that you can eat, and honestly, you don't really eat it so much as like we use it in cooking and baking, is baking soda. Baking soda is sodium bicarbonate. It is a base. So if you ever like kind of dip your finger in the baking soda and taste it like when you're baking, it doesn't taste that great. It tastes bitter. But we use like little bits in baking, you know, like a teaspoon or a couple teaspoons, because since it's a base, it will react with other things in our dough and our mixture, and it will produce carbon dioxide gas bubbles, which causes like cakes and cupcakes and things to rise, or like cookies to kind of rise a little bit, depending on how much you add. So we use it in small amounts in like baking things because of that chemical reaction that it does, and it helps the things to rise and get larger with the gas bubbles it produces. But like nobody's eating like entire spoonfuls of baking soda just by itself, because number one, it tastes really bad. And number two, if you ate enough of it, I don't know the exact amount off the top of my head, but it can cause you to get really sick. Pretty much all the other bases are going to be really, really dangerous things. Any kind of cleaning product is a base. So anything that's like under a sink in your house is going to be basic. Soap, shampoo, conditioner, body wash, even stuff like drain cleaner, Windex, bleach, all of those things are bases, and all of them are usually highly, highly poisonous or toxic. They have those warning labels on them like, don't eat this, don't consume this. If you do, here's the poison control number. Okay. Because most bases are highly, highly toxic. We don't really eat them because they're not anything that we can really eat very well. Okay, so they increase the concentration, but they're different ions. So acids are associated with the hydrogen ion, because when we did our names and formulas for acids, bases, if you guys remember from last semester, all the acids, kind of their characteristics for their chemical formulas was they all started with hydrogen. And so when you have an acid and you dissolve it and it's in a solution, it's going to have a very high concentration of hydrogen ions in that solution. Bases, on the other hand, if you guys remember when we did the names and formulas for bases first semester, bases all had hydroxide in their formula. Now, there is a slight different definition for bases. They don't always have hydroxide ions in their formula. There are some exceptions that we'll talk about later, but most of them do. And so the characteristic for bases is when they're dissolved in a solution, they're going to have a high concentration of hydroxide ions in solution, typically. Here's something that they both do. They both can be corrosive. Corrosive means that they can like react with things and like kind of eat away. So they could be corrosive to metals or to our skin if they're concentrated enough and they're strong enough. Strength and concentration are two different terms when we're talking about acids and bases. Concentration is like molarity, like we talked about in last unit. Strength has to do with kind of the type of acid or base, and that's kind of what we're focusing on today, is the difference between strong and weak. And that has to do with how much they split apart into ions in the solution. They're both electrolytes. I kind of already mentioned that at the beginning. So both of them are going to split apart into ions and conduct electricity. It's just the strength is going to determine how much electricity they can conduct or not. And both of them are going to change the colors of an indicator, like that litmus paper I mentioned, but they're going to change different colors. So that's why indicators are something we usually use to identify if something is an acid or if it's a base. And then there are some indicators that are more specific, that they actually turn different colors at different pH levels. And so we can kind of look at the color that it turns, and we can kind of do an estimate of, oh, the pH is about 6 or it's about 8, or, you know, whatever. We have a scale we compare it to. So I kind of already talked about the litmus paper stuff, so I'm not going to go over that again. There is a little video here. I would definitely encourage you to do it. It's got an overview of kind of acids and bases, the strength and weak stuff we're going to talk about. So definitely, if you haven't already gone through that, definitely take the time to watch over that when we're done today before you get started with your activity. And then you have a couple questions down here to check on this intro information before you move on to your activity today. So you're at the rest of today, you're mostly doing this simulation activity. So this is the one where I told you it's up here embedded if you just want to leave in everything in Canvas and work in Canvas. Or here you can click this link and you can open it in another window or another tab if you prefer to have them open separately. Okay. Once you open it, whichever way, you're going to choose introduction, which I already clicked on introduction earlier on the one that's embedded. And then there's a couple things you need to make sure you have set before you get started in the views panel. You want to make sure the tick box for solvent is checked. So I'm going to go right here. Here's the views box. Here's solvent. I'm going to check this box. What it's doing is it's showing me the water molecule. So if it's unchecked, all I'm seeing right now are like the acids and the bases, okay? The hydrogen ions and the hydroxide ions, okay? If I check solvent, now here's all the water molecules. So all that gray, here's my chemical reaction. So I got water molecules, and then I'm getting hydronium, which is kind of used in place of hydrogen ion. And then here's the hydroxide ion. Okay, so the blue, notice it's blue because that's associated with bases. Notice this one's red because hydronium is equivalent to the hydrogen ion, and it's red because we associate that with acids, okay? So I'm gonna add the solvent. In the tools panel, I wanna click on the light bulb to show the conductivity tester. So there's different tools over here. There's this, which is a pH meter. There's this, which is, it's not litmus paper. This is called pH paper, and it uses this thing called universal indicator. So this is one that's more specific. So like I said, it's gonna turn a lot of different colors, and it can, instead of just telling us red is an acid, blue is a base, it's gonna have all these colors that can tell us approximately what the pH is. But you wanna do the light bulb right here, okay? Because we're concerned with strength, which has to do with can they conduct electricity or not? Because are they electrolytes, strong electrolytes, or weak electrolytes? So that's why we want the light bulb one. So, and then here's just pictures to help if you need that, okay? And then what you're gonna do, you're gonna dip the electrodes in the solution. So you're gonna click on one of these red or black areas with the plus or minus. You're gonna dunk it down into the solution, because what we're doing is we're completing a circuit, okay? So right now, here's the battery and here's the light bulb, but it's not connected because these electrodes, they don't have anything to connect electricity between them. When I dip it into solution, see what's happening to the light bulb? It's coming on. Okay, it's now on. If I put it in here, the light bulb's now kind of got this little glow around it. That's because by putting it in this solution is an electrolyte and it conducts electricity. So by dipping those electrodes, that positive and negative end, into the solution, I'm completing the circuit, because there are free flowing ions, these positive and negative ions right here, they're floating in that solution and they can conduct the electricity. They can carry the charge from, this positive to the negative. All right. So I'm going to dip it down. Okay. Once you dip it down, you can go on to this next page, and this is going to go through what you're going to actually do. So you're first going to compare strong and weak acids. Okay. That's the first part. The second part is strong and weak bases. Okay. So you'll and there's some pictures and guidance there. And then you're also going to compare what's like strong acid versus strong base. Like, how are they different or the same? Okay. So you're not, and then weak acid, weak base. So the last two, you're not really having to do anything different with the simulation. It's more of kind of things you observed and based on the definitions. But the first two, it's kind of guide you through. So it says in the solution panel, choose strong acid, and then you're going to observe the light bulb, the molecules, and the chemical equation. So right now it's just water. I'm going to click on strong acid. Okay. So then it says switch to weak acid and observe the same thing. So I'm looking at, so right now it's on strong acid. I'm looking at the light bulb, I'm looking at my chemical equation here, and I'm looking at all the molecules inside here. Okay, so make sure you're kind of observing each of those. And now I'm going to click on weak acid and we're going to compare it. So, and you can click back and forth if you need to kind of look back and forth on what is changing from one to the other. So what's something that you see changing between the strong and the weak? Anybody want to volunteer or say something in the chat? So we're supposed to look at three things: the light bulb, the molecules here kind of underneath the magnifying glass, and then this actual chemical equation. So what's the light bulb doing when I go from strong to weak? Is it getting brighter, dimmer, the same? No change?
It gets dimmer when you go to weak.
Yeah, it gets dimmer because on strong acid, like, look, there's all these rays coming off of it. But when I go to weak, there's still some, but it's not as bright. Okay. What about here under the magnifying glass of like the number of molecules that I can see? So here's the strong acid. Here's the weak. So what do we notice is happening? So it looks like, so here's the strong acid. I can see lots of these red and blue, right? And the red and blue, that's over here. So the red is going to be that, it's called the hydronium ion, which represents the hydrogen ions. And the blue is going to be the negative anions. That's why it's got this A with the negative, because it's just kind of a generic anion. We don't know what it actually is. So in the strong acid, there's lots of these that have the positive and negative charge. When I click on weak acid, there's a lot less of them. There's more of the acid molecule, okay, this dark gray. That's because strong acids fully dissociate. So do I see any dark gray right now? This one that's like the HA, that's this dark gray with the two.
No.
Yeah, there's none, right? I just see water, and then I see all of the two things that are on the product side here, okay? But when I click on weak acid, I still see a lot of that dark gray, a lot of this, the acid, because it does not fully dissociate because it's weak. And so there are some of the ions that are on the reactant side, or I'm sorry, the product side, but there's a lot more of this acid, whereas with the strong, there wasn't any. The last thing is the equation. So here's the strong acid. So here's the equation, okay? So look at what changes when I click on the weak. What do you notice that's changing for the equation? Because the reactants and products are staying the same. What's the only thing that's changing? It's right here in the middle. The arrow is the only thing changing. So the strong acid has a regular arrow because all of this acid, all of it fully broke apart and ionized and made these products. The weak acid, only some of it breaks apart, but these products, they can actually re-react the other direction and make more of the acid. So it has this double arrow. This is what we call a reversible reaction. So it means the products can actually reform the reactants and go backwards, okay? So you're looking at all that. And again, it's going to relate it back to Unit 9, the electrolytes, conducting electricity, all that kind of stuff. It's going to kind of guide you through here with some terminology. All right. So there are some words down here you're going to kind of read through, and after you kind of made your observations, you're going to drag and drop, and you can check yourself to make sure that you are answering them correctly. Then you're going to do the same thing, except you're going to compare strong and weak base. So again, you would just click here, strong base. You can do your observations. You can do weak base. Okay, do your observations, kind of similar. And then same thing here, after you've done your observations, then you're going to kind of draw some conclusions and answer these questions by dragging the words into the boxes. The last two for comparing like the two strong ones on the two weak ones, you're not really necessarily doing anything new with the simulation, but you can go back up here and do it if you want. Like I can click on strong acid, okay? And then I can click on strong base and kind of see like, well, what's similar, what's different, okay? And I can do the same thing for like the weak acid and the weak base and kind of see like, well, what are some things they have in common and what's different about them, okay? All right, so once you've done all the activities, all the questions there, your last part here, it just kind of goes over the fact that there's not really like a clear, precise rule for identifying strength of acids and bases. It's not like we can say like, oh, all of this is going to be strong or all of these are going to be weak. But there are some patterns, okay? For acids, except for hydrofluoric, acids that are paired up with halogens are strong. So that would be like a hydrochloric, iodic, hydrobromic, okay? Just not hydrofluoric. And then if you have a hydroxides with alkali metals, any of the metals in group 1, those are all going to be strong bases. And then the hydroxides of some of the alkaline earth metals in group 2 are strong bases. So this table lists the strong acids and bases. So if it's not on this list, it is weak. So the best thing to do is to memorize these on this list. There's 7 acids and 8 bases, I believe. And if it's not on this list, it's weak automatically. So if you remember these 15, then everything else would be weak if you were asked to sort of identify, is this strong or weak? Okay. So here's the hydrochloric, hydrobromic, hydroiodic. Those are the halogens that it mentioned up above. The other four all have polyatomic ions. So nitric acid has nitrate, sulfuric acid has sulfate, chloric acid has chlorate, and perchloric acid has perchlorate. The bases are going to be, they're all like group 1 and 2. So lithium, sodium, potassium, rubidium, cesium, those are the group 1 alkali metals with their hydroxides. And then it said up here that some of the alkaline earth metals, and the sum are these 3, calcium, strontium, and barium. Notice they have the 2s outside the parentheses because remember all the alkaline earth metals are positively positive 2 charge. So that's why we have to have 2 hydroxides for them. Okay. And then there's some questions down here where it's going to ask you about sort of like some real life things. So this one's asking about Drano, which is drain cleaner. This one's about Windex. This one is toilet bowl cleaner. Tomatoes, lipstick. Why does it have the red color? Okay. So kind of some, because acids and bases are pretty much in our house everywhere, every day. We come in contact with a lot of them. We eat a lot of acidic stuff. A lot of, like I said, all the cleaning stuff should be basic. But, you know, and if we know about them, sometimes that can help us, you know, with doing things around our house or making sure we're safe and that kind of stuff. When you're done with everything, again, make sure you come to this last page, make sure everything is completed, and then make sure you hit the green button, submit report. That's the only way it goes into the grade book. If you don't hit submit report and you leave this page, it's not going to send it to the grade book, and then you're going to have to redo it because I'm going to say I don't have a grade for you. Okay. So make sure that when you're doing it, that you submit the report. So it goes, because it'll automatically go through to the grade book on Canvas. And then I will be checking over the weekend to see what was done, you know, by tonight at 11:59. Well, actually not for this one. I'm sorry. I'll only be checking for the unit 9 stuff for progress report. This grade will be after progress report. Okay. So make sure you're working on, if you're behind on stuff, guys, please make sure you're working on getting the unit 9 activities done. And then that unit 9 test. If you want that to count on progress report, it has to be done by 11:59 p.m. tonight. Okay. After tonight, I can't count anything until after progress reports. Okay. All right.